Hello, good afternoon. Can you understand me? Okay. Here on the picture you see the fastest way to become DBA. You need only a small tool called Knife and a telephone dictionary. So you visit the DBA at home and then access the company network. But I expect that we will see this in future, but not now. But the talk today is about Oracle rootkits, second generation. And before going to the second generation, I explain also a little bit about Oracle rootkits first generation and advanced versions of first generation rootkits. Then about different possibilities how to implement database rootkits in Oracle. And then some conclusions. I work for Oracle for Red Database Security, and we are specialized in Oracle security only. And it's fun to work with this software. Okay, the first talk about Oracle rootkits I gave last year at the BlackHat in Amsterdam, but my problem was I gave this talk at the 1st of April. So many people thought it's an April's Fool, but that's not true. It's real and you can try it at home in your private database. A few years ago I made the observation that operating systems and databases are quite similar in the architecture. In both you have users, processes, jobs, executables, you have even something like some symbolic links. In Oracle you can even change directories. And then I made the assumption, okay, a database is a kind of operating system. And to prove this, I made a small table. For example, we have the OS command ps to show all processes. And in Oracle, the command is select staff from $process. Then we can kill processes with alter system kill session. We have executables like views, packages, functions, and procedures. We have execute command. So by select staff from view, we can execute the view. We can execute procedures, and we can even change something like directory with alter session set current schema. And then I made the assumption, okay, if a database is a kind of operating system, then it's possible to migrate all the malware stuff from the operating system world to the database world. And my first approach was to implement an Oracle virus based on a view, and I implemented this and it worked. It was just a proof of concept. Okay, before coming to database rootkits, what is a normal operating system rootkit? Normal with an operating system rootkit, hackers are using this to hide their presence on a system, or some music companies are using this to protect their music from being stolen. For example, last year, Sony released the Sony DRM rootkit, and this rootkit was hiding every executable containing a $Swiss dollar. So if the rootkit was active, you saw nothing, even in the task manager, and if the rootkit was not active, you could see this executable. The same is also possible on Windows, on Unix. On the right part you see nothing, on the left part you see that the user hacker logged onto the system. And all the rootkit stuff on operating system is quite old and exists since 15-20 years. Okay, so my goal was, after migrating a virus, was to migrate a rootkit. So instead of using the operating system, we are using the database. Instead of hiding an operating system user, we are hiding a database user, database jobs, and processes. So the most fundamental parts of the database. And generally, there are two different ways to implement a first generation rootkit. The first way is we can modify the database object itself. And the second possibility is we can change the execution path. And I expect the evolution in different types of database rootkits. The first generation, presented last year at the BlackHat Europe, is a modification in the data dictionary. For example, we are modifying a view or changing a synonym to change the content. The second generation, presented here later, is there's no change in the data dictionary, and that's why it's much more difficult to detect. And the third generation works directly on the memory of the database, and Oracle was so kind to deliver an official API since Oracle 10G Release 2 to do this. But this is still future, third generation. First generation, easy to implement, easy to find, but even then, most DBAs never heard of this term and they are never looking for this kind of modification. Microsoft was, last year after they saw the presentation, they changed their SQL Server 2005 and they implemented a simple anti-database rootkit technology. So they're using digital signed views, and if you modify a view, you're getting a warning during the database startup. So Microsoft is taking this serious, and they did their first protection against it. Oracle did nothing. Before modifying objects, we must think about how is Oracle resolving object names. So what happens if you are submitting a statement, select username from DBA users? Then Oracle checks first, is there a local object in the current schema called DBA users? If yes, use it. Normally there is no such object in the current schema. Then it checks for a private synonym called DBA users. If yes, use it. Then for a public synonym. And normally there's a public synonym called DBA users. And depending on the object, Oracle modifies the SQL statement afterwards if virtual private database, VPD, is active. So it's from top down. It checks first in the user schema for table or views, then for private synonyms, and for public synonyms, and then it accesses the original views or tables. And now we have different possibilities to modify the execution path. One possibility is we can create a local object with the same name. For example, in the system schema, we can also create a private synonym or modify a private synonym pointing to a different object. We can create or modify a public synonym, or we can switch to a different schema. All these four ways are able to modify the execution path. Okay, user management. How is the user management done in Oracle? For a historical reason, Oracle is storing users and roles in the same table called sysuser$. Users have the flag type number 1 and roles have the flag type number 0. And to simplify the access, Oracle has two views, DBA users and all users, and public synonyms. So everybody in the database can at least access the all tables, the all users, or if the user has DBA privileges, he can select staff from DBA users. Now we are creating a user called hacker. With the weak password hacker, a good hacker would normally never use the username hacker. He would use something which sounds like an Oracle database account, like mtsys, for example, and he normally uses a better and stronger password. In the next step, we grant DBA privileges to this user. And the problem if the DBA in the morning look into his database and checks all the users with select username from DBA users, we see here that the user hacker is active. And now we try our trick. And here, nowadays, a lot of DBAs are using graphical user interfaces. So we can see the user hacker in Enterprise Manager and Database Control or in Toad from Quest. And now comes the trick. We are modifying the view DBA_users, and we are adding one single row, and uname not equal hacker. This means show everything except the user called hacker. There are many possibilities to remove the user hacker from the output. So you could also say and u.id not equal 47, something like this. And surprise, after doing this modification, the user hacker is gone in Enterprise Manager and Database Control. So you can't see it. And also if you do a select staff from DBA users, the user is gone. Only Quest Toad is using the user is visible in Toad. The big question, is Toad a better and more secure product? No. Toad is using a different view. So if we modify the view all users in the same way, by adding this end uname not equal hacker, the user is also gone in Toad. You can still log on to the database using the user hacker, but it's no longer visible. And in this case, if you select star from DBA users, you select the public synonym. From there, you access the view, and here in the view, we did the modification. The process management is quite similar. You have also some special views. And with select SID serial number from $session, we see also objects from special users. And then by doing some modification, we can also hide the running sessions of the hacker. The same can be done for database jobs, because sometimes it makes sense if you want to survive an update to set up a database job. And every night you run a database job, and this database job checks if the rootkit is still active. And if the rootkit is not available, for example, after doing an upgrade or a patch, you can implement the rootkit again by running a database job. And that's why it's useful to hide database jobs. Here we create a simple job. And here we can see the user hacker, and his job is active. And now we modify p-owner not equal hacker, and then the user hacker is gone. But it still works. Now I show some examples. To generate a rootkit, you can run the following select statements. Oracle has a package called DBMS metadata. With DBMS metadata, you can generate the DDL statement, the DDL code of an object. So here we say DBMS metadata.get DDL from the view all users. And then we replace the where with where username not equal hacker. And the result of this select statement is written into a file called rk_source. And we are doing the same for the view DBA users. And then two modified views containing this where username not equal hacker are now contained in the text file rk_source. Then with spool off, we disable the spool file. Then we create our hacker with a stronger password, and then we execute the view command. And then we replace the view all users and DBA users, and our user hacker is invisible. From the concept, this is quite easy to find. One thing you can look up in the view, but most of the DBAs are not doing this. Instead of using the view DBA users or all users, you can access the table sysuser$ directly, because then it's, even if someone modifies the view, you can still see the unmodified data in the base table. Okay, if you now try to make a little bit more advanced rootkit, which is much more difficult to find,